Hello, everyone. Today is July 12th, 2022. My guest today is Justin Gravett. Justin is a systems engineer and the co-founder of Canopy. Thanks for coming on the podcast, Justin.
Yeah, thanks, Krish.
What is Canopy?
So Canopy consists of myself and David Ashton, my co-founder. We're up in Portland, Oregon, and we started this company about a year ago through a National Science Foundation Phase 1 SBIR grant. And what Canopy is doing is developing fully autonomous robotic greenhouses that use cost-effective automation to allow more sustainable fresh produce to be grown close to the consumer. So basically our technology is a turnkey solution to farming. So these greenhouses are about 1,200 square feet, take up about a quarter of a basketball court or 5 parking spaces, about 20 feet tall. And they produce about 2 acres equivalent of produce fully on their own without any human intervention involved. So these farms can do everything from seeding, transplanting, watering, and all the way to harvesting, all through robotic systems. The idea for these farms is to market them to retailers. They could put them in the back of their parking lot, cut out their supply chain, and kind of integrate vertically their fresh produce supply, primarily leafy greens and herbs right now, and also to provide this technology to small-scale farmers so they can benefit from the automation that large-scale farms have for many decades that hasn't been as accessible to small-scale farmers, which are really struggling right now due to labor problems, climate change, all sorts of things like that. So that's so far we've just built our subscale prototype. That's what we did for the Phase 1 grant, and that demonstrated all of our robotic systems. So we were able to grow leafy greens and herbs in that system all throughout their entire life cycle without any human intervention. So the robotics did the seeding, the transplanting, the harvesting, and the extent of the automation in these farms is that they'll be able to run for a month at a time without humans needing to do anything. After a month, they'll just need refills of seeds, media, which is kind of like a sponge-like dirt that the plant's growing. And that's pretty much it. So we think this is kind of one of the most automated farms that's ever been designed. Our next step is to just build the full-scale version of it and test it out and confirm all of our estimates that we have for its operational costs, yields, things like that. So that's where we're going next.
Wow. How did you and David come up with this idea to start an automated farm?
Yeah, so it's actually David's really the mastermind behind it. He kind of just recruited me to make it all work. Tim and I both met in college at Cal Poly. We actually were roommates together our sophomore year. We shared a room for a whole year, so figured we could at least work 8 hours a day together. But he was working in Portland for an engineering firm. His background's in mechanical engineering. He studied bioresource and agricultural engineering at Cal Poly, which is kind of an agriculture-focused side of mechanical engineering. And so he already had that agriculture background. But in Portland, he was working for companies like Facebook or Meta, developing like AR, VR systems, and kind of just wasn't really enjoying it. Kind of seemed like it was doing some negative things towards humanity potentially. Just wasn't really liking where it was going. So we wanted to do something that would have a much more positive change, and in a way to help farmers, help our agricultural system that's really suffering from a lot of major issues that have become a lot more apparent recently with COVID and conflict in Ukraine and all sorts of things like that. So he came up with the idea for the most part. He kind of moonlighted this. He was doing a lot of the design work. Just he'd go home and just work on this side project after his main job. So he came to me with this like 80-page business plan, which was just crazy. But he showed it to me, just asking for kind of some feedback and everything like that. And I thought it was super interesting. He needed software and electrical support, which my background is in primarily through aerospace industry. And he hadn't really heard of these small business innovative research grants before, but I'd had a lot of experience working at ES Aero in San Luis Obispo before. So we decided to apply for one. First one through NEFA, which is the USDA, was not accepted, but then our next one to the National Science Foundation was accepted. So we got a little over $250,000 to start the company and build a prototype over an 8-month period of time. And so I moved up to Portland and we started working on it. It's been exciting and pretty fun to do, but lots of hard work and lots of learning involved, because first time either of us have run a business before. So lot to it outside of just the engineering part, which was the main focus of why I joined in.
What are some of the most difficult or unexpected non-engineering aspects of starting this business that you've gone through?
Yeah, so all the just administrative stuff. I never used QuickBooks and done all that accounting type of work, and that's really important to the way we're spending the government's money. We have to make sure we're tracking that and using it correctly. And so yeah, all the QuickBooks and accounting, and in relation to that, all the tax compliances, trying to understand everything, and it's definitely complicated. And we hired a CPA, we have legal counsel, but also asking them questions all the time is just going to cost a lot of money. So had to learn at least the basics ourselves. In addition to that, just setting up the company with finding the office, getting appropriate business insurance, and trying to do all this as quickly as possible so we could start building the prototype, because the way we kind of proposed the work we were going to do is almost as if we already had our office set up. We were just able to hit the ground running, and that really wasn't the case. I had to move up to Portland. David had to leave his former job. Is a little bit more to it than just starting as we had initially proposed. And then outside of the engineering part and just like the general administration stuff for the business, all the business development side of things. So when we first started to fundraise for outside investors in January or so this year, we were very, very inexperienced. Our business model was needed a lot of work. And after meeting after meeting after meeting, we kept getting advice from various investors and people in the industry, or people that have experience with running small businesses and growing technology companies, and eventually kept refining it until we finally kind of got something that made sense to people. And so that took a lot of work. I mean, we're still currently in a business accelerator called the Cascadia Clean Tech Accelerator, which is almost like business school for startups, and learning a ton through that as well. So like I said, I was in the engineering field for about 6 years before coming here, and all the business side of things was completely new.
Yes, and it can be overwhelming.
Oh, definitely, especially while trying to focus on the engineering side of things, multitask.
Yes. How have been the engineering tasks that you've taken on?
Yeah, it was a lot to learn. I mean, I didn't have any agricultural background. My experience is with aircraft and drones, things that are usually up in the air. So most of the hardware that I was working with was completely new to me. Never really used the types of motors and actuators that we had in the farm, the different sensors that we have, and just automation wasn't something I had experience with. I just had the electrical and software background. So learned a lot in terms of that. But one of the biggest things was actually learning how to grow plants. Both of us had only grown like house plants before. And so trying to figure out and learn how to grow hydroponic vegetables that are high quality, and develop systems to grow them autonomously to a very high standard. Kind of had to do a lot of trial and error involved with that. There's a lot of information you can find online, but getting it fine tuned and everything like that, and specific for our system, took a lot of learning. Killed a lot of plants, but we were eventually able to get some pretty healthy looking harvest out of the farm.
What's the reason you currently are focusing on leafy greens and herbs?
Yeah, so since we're growing hydroponically, we can never really grow any root vegetables. So hydroponic means you're growing in water. That water has nutrients in it, dissolved nutrients. Those get fed to the plants. The plants absorb the nutrients in the water. Once the water is depleted of nutrients, it's drained from the away from the plants, recycled into the system. So it's being reused constantly, the water, and more nutrients are added, and that process repeats. So because we're growing hydroponically, it's a closed loop system, so it can use around 90% less water than traditional agriculture, which is a huge savings. That's pretty important right now. And the reason why we're growing leafy greens and herbs specifically is because, we can't grow anything that needs soil, that grows underground, like carrots or onions and things like that. Next steps is we'd like to get to vine ripe produce, which would be tomatoes, cucumbers, strawberries. However, the robotics to harvest those types of crops are a lot more difficult to design. Those would require computer vision systems, and right now all of our harvesting robotics aren't using any computer vision whatsoever, which allows it to be really robust and kind of effective and consistent. But we'll have to develop some more complicated mechanical devices and computer vision systems to be able to do that in the future. But it's definitely something that we'd like to head towards.
Yes, that would be amazing.
Mm-hmm. And
If
one other, oh, sorry.
No, go.
I was just going to say one other thing that we can do and have done is we could do plant starts. So something like a pine tree or whatever, any sort of really large type of plant, we could at least get it started in our system the first month and a half of its life or so, and then it can be transplanted to soil and grow from there. So that's something that we've done with a couple of crops that we couldn't harvest, but we were at least able to get them started in there.
That's great. And with these vine ripe vegetables, that would be interesting, because then that computer system would have to know what's not, a premature vegetable, what's a ripe vegetable, and what's an overly ripe vegetable.
Yeah, exactly. And the other factor in that is those types of produce all require pollination. So we'd have to introduce bees into the system or robotics that can do that pollination for us. Because it's basically those, strawberries and tomatoes, they start off as a flower, they get pollinated, and then they turn into a fruit.
Wow. So you have learned a lot about agriculture in this process, as you said earlier.
Definitely.
And earlier you mentioned that we're seeing huge problems with our traditional forms of agriculture. What are those problems? And they've been highlighted through things like COVID. What are those?
Yeah, so it's kind of a handful of them. As our population's been growing, we've been needing more food. We're starting to run out of arable land in America. We have to import a lot more of our food now, and that the percentage of fruits and vegetables that we import is growing more and more every year. So with that comes longer supply chains, more emissions related to that. due to shipping produce, and the produce is going to be lower quality by the time it arrives. So that's one side of it. And then COVID really messed up supply chains. So that caused a lot of markets to not have any bananas for a week, or not have another crop for a week. So that was pretty apparent that something that we could improve by having the growing process be closer to the consumer. Traditional agriculture also uses a lot of pesticides and herbicides, and since we're going to be growing in a controlled environment, we should be able to very limit the amount of pesticides and herbicides, or completely eliminate them, which will make the produce healthier and cleaner, basically. There's some other ones. Labor. Yeah, so I'm not sure, that's not too related to COVID maybe, but just in recent years, labor has been extremely growingly hard to get, really hard to find farm labor right now. The average age of farmers is actually like 58 years old or something like that. So farmers are not really being replaced by the younger generation as quickly as they need to. So that's a major concern. A lot of people who are young they don't want to be farmers, because farmers, it's a really tough job. Probably aren't going to make a ton of money. You're getting dirty in the field. It's a lot of work, a lot of time. So a lot of younger people aren't really jumping to that as a highly desirable career. So hopefully with our technology, it can give opportunities for younger people who want to get into farming, to be able to do so, and really kind of lower the barrier to entry, basically, to allow more people to become farmers and grow the food that we need, so we don't have to just keep importing it from other countries. Another one, climate change has been problematic. Last year there was like a 120-degree heat wave here in Oregon that wiped out a lot of crops. This year,
Yes,
it snowed in April, so that destroyed crops too. So it's been really challenging for farmers to deal with all these climate change issues, and growing in a controlled environment can at least mitigate those.
yes. The age of farmers is really interesting. And how do you think that's going to play out in the next few decades? And how do you hope Canopy and companies that like Canopy are going to shape that path?
Yeah, I mean, it's hard for me to say. I'm not really too sure what exactly is going to happen, but I think we'll just either hopefully solutions will catch up by the time that becomes more problematic, because we're not the only ones trying to grow food closer to the consumer. There's a lot of companies out there. It's called controlled environment agriculture, or CEA. You basically have warehouse farms. So those are people like Plenty is probably the biggest player. They're growing in empty warehouses, basically, in places like Los Angeles and San Francisco. And so that's one option. There's also a lot of people doing container farming, so repurposing shipping containers and growing food in there. And greenhouses have been around for a really long time too. So those are all different controlled environment approaches to agriculture. And there's actually also people doing in-store farms as well. So that's actually having farms that are inside the grocery store. And so these are all getting a lot of interest and a lot of investment. The market is growing substantially and very, very quickly. And there's companies like Amazon and big companies like that who have invested in companies like Plenty, because I think that the need for an alternative to our traditional approach to agriculture, or at least an alternative path. We could still definitely have both, but at least having more options seems to be pretty necessary right now. So, we believe our solution is a better approach than these other options, warehouse farming and container farming, because we're kind of trying to combine the best aspects of all of these. So with greenhouses, you get to use natural sun lighting, so you're not spending a lot on energy. So warehouses and container farms, they use LEDs exclusively to grow produce. It's very expensive and likely isn't coming, at least right now, from a sustainable energy grid. So having a clear rooftop allows us to use natural sun lighting and just use LEDs to kind of make up for what the sun can't provide, especially up here in Portland where the sun doesn't come out very often. So that allows us to, in part with the robotics and being close to the consumer, allows the price to be a little bit lower for the produce that would be output by our farm compared to other competitors. Right now, farms that are in warehouses and shipping containers, the produce is very, very expensive. It has to be for them to be profitable because their cost of labor, energy, everything else involved is very high. So right now, the majority of controlled environment agriculture companies that are selling produce, that produce is unaffordable to most. Most people aren't willing to spend significantly more than the organic version that's just grown traditionally. So hopefully this will allow our technology to allow the cost of that of growing produce in these ways to be reduced substantially and allow more typical people to access it and have healthier, more fresh produce.
That'd be great. And you mentioned that your system is one of the most automated agricultural robotic systems.
I'd probably say the most, let's see, how David always phrases it better than I do. He said like the most automated farm in the world.
Okay.
Yeah.
That's got to lower cost a lot.
Mm-hmm. Yeah, exactly. And since all of our robotics are designed custom, we're able to drive those costs down a lot. We're not just getting like an off-the-shelf robotic arm that a lot of people are, or companies are trying to repurpose like existing greenhouses with robotics and, warehouses with robotics. But since this farm has been basically designed around the robotics, it allows it to be a lot more efficient and more optimized and lower cost, essentially.
What do you mean designed around the robotics? Oh, instead of the robotics just being a different piece of robotic being integrated in the system?
Exactly, yeah. The farm and the robotics have all been designed together instead of just trying to fit a robotic system to an existing farm.
That's a very interesting, I don't know about interesting, but I think that's a really sound structural system when it comes all together. One good example is Apple. Their hardware and software are, they're one system. It's not like any Dell, HP, any sort of computer, and then a Windows OS, which can be adapted to any of those computers. And you believe that makes your system, what do you think that does for your system?
So just kind of make sure I'm understanding the question correctly, just the fact that it's an integrated system.
Yes.
As a whole.
Where the hardware isn't being developed out of it's being developed in Canopy.
Yeah. I think that's huge. I think, because we can develop our intellectual property around it, it's going to be hard for other companies to take what we've done and try to mimic it and be able to basically catch up to us. Because we know, if we're successful with this, we think other people are going to come chasing after it. So I think it gives us a little leg up on any competitors trying to do something similar. And we're always going to be modifying it. We're always going to be improving it, and so that'll increase our competitiveness. Like what I mentioned earlier, with introducing new robotics for strawberries and cucumbers and things like that. That'll just keep making our farms better and better. And we can even go out, and since we have technicians that know how to run the farm, know how to work with them, we could upgrade existing farms for our customers.
Nice. And the operations for those customers, I'm assuming, isn't very complex since it's an automated farm.
Yeah, exactly. It'll be as easy as just opening up an app on your phone and saying what you want to grow, and the system will do the rest.
Wow.
Yeah.
And you said that it only needs to be, someone needs to look oversight and at once a month.
Yep, that's what we're predicting, at least. That's what at least we've been able to sort of test and demonstrate so far, and what we think is feasible. Mostly it's the media that I mentioned earlier. That's the only soil that we use in our farm. And it's each seed needs a media. And so if we're doing 250 plants a day, that's 250 media that we're going through a day. That adds up to a lot of media input and then media composted out of it. So that's the biggest kind of volumetric input to the farm, except other than like water, which is just coming from a well or a faucet. And so we will need to refill the media every month or so.
And the system harvests the plant, you said?
Mm-hmm. Yep. And sorts it into different bins. So the user would just grab a bin of the harvested plants. So that's why like stores in the Pacific Northwest that we talked to are really interested in our farm and having it in the parking lot, because their employees would not need to learn anything new. They would just basically keep doing what they were already doing. They would run out to the back, grab a bin, and put it on the store shelf. They wouldn't have to, do the harvesting or anything like that.
And that's a huge part of being a product engineer, is designing that simplicity into your product.
Mm-hmm. Yeah, and we definitely have learned a lot just from talking to potential customers and everything like that, doing customer interviews. It's definitely a very important thing, the customer discovery side of it, because that makes a huge difference in terms of how we develop the technology. And right now, since we still haven't built the full scale, any sort of things that we learn that customers would want, we can go ahead and design in already. There's still a lot we need to learn about in terms of developing our farm, and things like seeing what we could do to get organic certification, seeing what different cleaning standards we need to follow. How robust is it? Is it ever, how often does it break down? Things like that we'll have to be learning along the way. But it just takes doing it to figure that out.
Yes. What's the biggest change you and David have made based on customer feedback?
Let's think. So I guess right now we haven't really made any changes based on customer feedback, because we haven't really started designing the full scale. There's just kind of things that we've been considering. And customers have talked to us in Portland about, like addressing for vandalism, stuff like that. Like, so making sure, someone can't just come and damage it. And that's something that we weren't really thinking about originally. But considering these are going in Portland, might need to pay a little more attention to. And yeah, other customers have told us that, they wouldn't want, they want full heads of lettuce. They don't want like salad mixes. That's something that a produce buyer told us, basically does not like receiving salad mixes. He wants full heads of lettuce. And we were thinking, oh, maybe we'll just design some robotics to make pre-made salad mixes or something like that. And he was like, no, we want the full heads of lettuce. So yeah, there's a couple other things that I probably just can't think of off the top of my head right now, but if I do, I'll try to let you know.
So, but the full heads of lettuce would be easier for the system than a mixed salad, right?
Yeah, exactly. So that was nice.
Okay. Wow, that's awesome.
Yeah, but we're definitely not set on any like specific design features that we have in it right now. It's pretty adaptable. It's kind of easy to modify certain aspects of the farm here and there. And so still right now the design's a little bit flexible to, you know, be able to target our customers a little bit better.
Okay. What are some of the most valuable principles of robotics that you've learned since taking this on?
I mean, I didn't really know a whole lot about robotics in general to begin with. I'd done a lot of like, I guess, yeah, drones are robots. So I've done a lot of drone specific things, but you know, I never used like a stepper motor before. So those I had to learn. Never used PLCs before, so there's some learning to do there.
What's a
so probably
PLC?
PLC is a programmable logic controller, and it's kind of like a industrial. I don't know the best way to describe it. It allows you to plug in sensors. It allows you to plug in, different like pneumatic actuators, different things like that, and it could control all of them. But the software to run those PLCs is a little bit different than anything I've worked with. It's called ladder logic. But yeah, so just things like that. They're a little bit more industrial than just using, microcontrollers and different devices like that.
Okay. What's a pneumatic actuator?
So that is a device that's basically run by air. So a valve open and closes to send air one way or the other, and that will move something in a linear fashion.
Okay.
So
By the force of that air.
Yeah, and I never worked with, it's compressed air. So we have an air compressor in the farm. So yeah, a lot of the farms run off the air compressor, and then just electricity for the motors and some of the sensors and things like that.
Wow. That is, so you also describe yourself as a systems engineer, and that is a very complex system, it seems.
Yeah, it definitely has a lot of parts, a lot of moving parts.
Yes. Has an electrical system, a software system,
Yeah.
water.
Yep. Yeah.
Light.
Yeah. Irrigation system. Yeah.
Wow.
Yeah.
What?
A lot of chemical side of things too, with all the different, nutrients you need to put in the water, the pH balance, all that you need to pay attention to. So there's chemistry side of it. There's, the plant, horticulture side of it too. So yeah, it's a system with many different disciplines kind of built into it. So learned a lot. It would have helped if I actually got a degree in electrical or software engineering.
What was your degree in?
Is in aerospace engineering.
What do you feel was the biggest difference between an electrical or aerospace?
I just didn't really learn like very much coding in aerospace. I learned MATLAB, which is a really good foundation, but I didn't learn how to code in C++ or anything like that. Didn't learn any object-oriented programming, so that was something I had to learn at ESERA. Luckily, I had 5 years of experience working with it by the time I started at Canopy. And then I only took 1 or 2 electrical engineering classes at Cal Poly, so that was a lot of just Googling, I guess. over the course of at ESAero and at Canopy too.
Wow. And it's kind of amazing how that experience has now accumulated. I mean, especially over, what was the first position
Sorry, what was the first
that you
position?
said? Not Canopy, but
At ESAero. Yeah.
ESAero.
Mhm.
You know, you start off at ESAero as a very novice engineer, and then by the end, you're able to at least have the sort of tools to learn
Mhm.
to develop a very integrated system that you
Yeah.
really don't have much experience in.
Yep, definitely. I mean, ESAero was a great place to learn that. They were always doing multiple really fast-paced prototyping projects, really kind of new technologies, development, things like that. A lot of government grants to do research projects and partnerships with universities and things like that. So learning was just kind of expected.
Okay. What you said earlier that there is a sort of automation in large scale farming.
Mhm.
What is that automation?
Yeah, so that would be like big, huge combines and um, things like that. I'm not even really familiar with the names of all of them, but these are like you know $1 million machines, some of them. So
What's a combine?
combine is, I don't even forget exactly what it does. Sorry, I have to Google it because I think is it just harvest? Yeah, it's a harvester. So it looks like
Okay.
it's really used for like commodity crops like wheat, barley, um, basically just harvest very, very large quantities of that, which would probably take an individual 100 times longer to do or something like that. So those machines are very expensive. The average small scale farmer you know can't really afford anything like that, just off the money at least they're making from their 5-acre farm or something like that. And so with our farm, we don't want people to stop farming or anything like that. If someone's an existing farmer, we just want to give them the opportunity to have this additional source of produce that's reliable year round, um, less susceptible to climate, and not have to do anything to run it, basically, so they can still be working in the fields harvesting root vegetables or whatever else they were doing previously, but always have something where they have a reliable source of income and can make a little bit more money than they were previously without it.
Yes. And if all of the other produce get
Mhm.
destroyed for some reason because of weather or
Yeah.
climate,
They still have
those,
something to get some
yes.
income and
Yes.
yeah, and they wouldn't have to do anything new necessarily. They'd just be adding more produce to their existing supply and selling it at the outlets they were using before, whether that's going to a farmer's market, going to a one of those like produce box called CEA, no, not CEA, CSA box. There we go. Community sourced agriculture. That's really popular here up in the Pacific Northwest. Basically, a bunch of farms work together, and people can just go pick up boxes of produce from multiple local farms. Usually, small farmers aren't selling at retail outlets. It's just not profitable for them.
What is profitable for them?
Farmers markets usually is the best for small scale farmers, like in the 5 to 6 acre range or smaller even. Usually farmers markets or probably farmers markets first, then CSAs, then a distributor.
Okay. Where do you get your produce?
Right now, I just go to like Trader Joe's or wherever. But I used to be a part of a produce delivery box in San Luis Obispo, but I need to sign up for one here again. I definitely miss that. It's nice getting a bunch of local produce, and you never expect what you're going to get, so you have to learn how to cook new things. But
Wow. That
yeah,
sounds very interesting.
Yeah, I'd love to do that again here. I've been meaning to sign up and just haven't. I've been getting so much produce just from our farm. It's hard to, we were growing so much. We were just giving it away to all of our neighbors at the office. It's
Wow.
and this is a subscale prototype, and between just the two of us, it was way more produce than we could ever eat. My freezer was like full of frozen kale at one point. Finally got through some of that, and just there's only so much lettuce two people can eat.
Yes, there's only so much. That's amazing, though.
Yeah, thank you. Yeah, we were pretty happy with the quality of produce we were able to grow with pretty much zero experience.
Yes.
And,
Wow.
and,
I
and it'll
can't.
get better from there. But now we're working with a horticulture expert from OSU, who highly educated, has a lot of experience. We're working with other people that have some more expertise in the areas that David and I are a little bit deficient in.
That will be great, because if you guys want to scale this, you'll definitely need to bring in more people.
Yeah, 100%. Yeah.
So how long have you been involved with Canopy?
So I'm coming up on a year at the end of this month, but I was doing just unpaid work for Canopy kind of in the transition when I moved down here. I moved here to Portland July 6th of last year. So just a year at my apartment basically right now, and kind of just worked part-time for ES Aero as I kind of remote part-time as I transitioned to Canopy. So there's a little bit of overlap between the two also. But then just now, had to focus full time on Canopy. It's too much to be trying to do both, part-time software work and, be as dedicated as they needed to be to Canopy.
Exactly. You could
Yeah,
probably go.
I was just gonna say David started a little bit earlier than I did. He started, I think, in beginning of June, just doing the design work. There's a lot of upfront CAD to be done before I could even do anything. So
Wow. To create the robotics and the structure of the farm itself.
Yep, exactly.
Wow. And since since Canopy has become a real, you've gained investors, how has life changed for you?
Yeah, so kind of went through a slightly stressful time where we, weren't sure if we'd be able to, keep this thing going and everything like that, because the government grants that the one that we finished and the one that we just finished applying to, those have about an 8-month gap in between the time you have money. So you got to somehow figure out how to stay alive. We call it like the Valley of Death or something like that. And yeah, so fundraising was a little bit more difficult and time consuming than I think we initially expected. Definitely would not underestimate that in the future. Now we've heard people say it could take up to a year to fundraise, and we were trying to do it in 2 months. So we, kind of basically said we'd go, a month or two without pay because we were able to pay ourselves a salary and everything like that. I wouldn't be able to do this if I wasn't able to pay myself. So that was really lucky with the government grant that we got. And so, yeah, we were willing to go a little bit without pay, but then, we'd have to find something else to be able to pay our bills and everything like that. But yeah, we finally got our first investment from Onami, and that kind of gave us a little bit more runway. And then we had enough people committed by then where we were getting pretty confident, but we're still just waiting on more money to come in and still fundraising and everything like that. But now at this point, we're confident we have enough money in the bank now to go, at least another year with the addition of hiring someone. That'll get us to the phase 2, which will allow us to build that full scale farm. But we're going to keep raising more money so we can build that farm regardless of if we get the phase 2 and start building it sooner. I'll keep, trying to move quickly and everything. But, the phase 1, a lot of technical work, a lot of, longer days and everything like that, trying to finish that all up. and get it ready so we could have something to show investors, because showing them a prototype was huge, especially growing produce. Being able to show the demo of the farm to investors was, basically, huge for being able to fundraise. So getting that working reliably, where it wasn't just gonna, miss or break or something like that while we're trying to do a demo to investor, took a bit of time and stress and everything like that. But once we got it down, pretty confident in it, then we're pretty much done with the prototype build for a little while. Now it's just been a lot of business management stuff, a lot of business development over the last 2-3 months, and now finally getting back into technical work. But right now, while David's on his honeymoon, kind of just trying to get our business a little more set up to be able to hire our first employee. A lot more that's involved in that. So, making sure we are following all the rules and regulations in Oregon and America to, hire our first employee and everything like that. So, overall, I think I don't know, definitely enjoy what I do. My life's changed just by moving up to Portland, but I feel like nothing else too much has changed or anything like that. I guess the amount of like meetings and networking and stuff like that, that's been a lot that I wasn't really used to before. But it's enjoyable too. So
Nice. So your workload, you haven't put more onto your workload or been forced to put more onto your workload?
maybe a little bit. I mean, I would have some pretty long weeks at ES Aero too. So wasn't like every week was a 70-hour work week, but definitely had a couple of them at ES Aero. And same thing with Canopy, I'd say. But the last like 2 or 3 weeks have been, very, very mellow. And so that's really nice to kind of get a little bit of a break for summer. Slow down a little bit before things start picking back up.
Yes. That is, those breaks are, I'm sure, very important in the long run.
Yeah, definitely. It might be the last one we get for a little while. So
What makes you say that?
just because the building the full scale farm is gonna be a lot of work involved in that.
And the full scale farm is a quarter of a basketball court?
Yeah, 1,200 square feet.
1,200 square feet.
Yeah, and we'll have to find a new office and to be able to build that farm outside, because right now we just built our subscale farm inside. We had an office with pretty tall ceilings, so we were able to do it, but we need to build this outside so we could get the sunlight and actually see how much energy we're saving compared to indoor farms.
Okay. How were you? So were you welding pieces of metal together?
No, so the farm actually has no welds in it. That might change in the full scale, but right now it's designed to be assembled and disassembled on site. So kind of like a kit. And so right now, no welds. We used a manufacturer called GK Precision, just south of Portland, and they are a manufacturer. They actually build a lot of combines and tractors and things like that. So they are in an agricultural industry with a lot of the work they do. But we would just send them the design files, and David dealt with all that as the mechanical engineer. But they'd bend sheet metal for us. They'd laser cut parts, and then another supplier we used was like Tube Service, which just does a lot of tubes, as you might guess, for a lot of the kind of primary structure, I guess, of the farm. Lots of 3D printed parts that David printed himself at home.
Wow.
Yeah, a lot. One of the components in the farm, he ended up having to print like, I don't know, like 1,000 of them or something. And each one would take like a few hours to print or something. It was something ridiculous like that. That was actually one of the most expensive part of the farms too, just because all that 3D printed material costs a lot. But we'll be able to make that out of plastic in the future, injection molded. So
Okay. So
that'll drive down cost. Yeah.
that one piece repeats 1,000 times in the system?
More in the full scale.
Wow.
A lot more in the full scale. Probably, I don't know. Like, I think there's like 80,000 or 8,000 in the full scale, or 80,000. One or the other. It's either 8,000 or 80,000 of these parts.
Do you think you'll end up outsourcing the printing of that?
We'll change it to be injection molded. So we'll
Got
design
it.
the mold. And then, yeah, we could, anyone could do the injection molding for us. I'm not sure who, but yeah, we're kind of playing around with long term, seeing if we want to outsource a lot of the manufacturing or do it in-house. It seems like outsourcing might be the better approach to go. Having another manufacturing company who's highly experienced in doing this and has all the equipment already,
Yes.
they're already set up to do this. It'll just be, additional work for them. Might be a better option than trying to, buy a giant warehouse, get a CNC, get a laser cutter, all that sort of stuff. So that would take a lot of capital to do. So it might not be the best option. It might be kind of better to have someone else do it, and we just have the designs and the manufacturing processes for it, and GK or another manufacturer could manufacture the farms for us.
Yes, you guys will have to make, you'll find out what's the best decision and do what's easiest for you two.
Yeah, that's a little bit down the road. Our first farm, we're just gonna keep ourselves, and we're gonna just sell produce to a restaurant in Portland here, called Amatera Winery. They have a restaurant as well, so they're interested in just buying the produce. And we're just going to have to be growing so much produce to test out all the robotics and everything, and go through multiple cycles of plants and everything like that. So we're just going to either sell that produce or donate it. And then after that, then we'll actually build a farm, install it on someone else's property, and and be a little more hands off and just have be customer support and technical support basically.
Well, hopefully it all goes, I mean, it probably won't go smoothly, but hopefully it goes as smoothly as it can.
Yeah, and luckily the early customers we've been talking to, they've at least indicated an understanding that it might break down every once in a while. It might not be perfect, and we'll adjust our long-term pricing model for early adopters won't be the same as or won't be the same as a long-term one.
Yes, for the later adopters, the early adopters, it's a very big deal what they're
definitely
helping you with.
Oh yeah, they gotta put in a good word for everyone else after them.
Yes. So what do you do when you're not engineering or doing networking or business/administrative management for Canopy?
Yeah, so a lot of just exploring. Portland still has a lot to do, especially compared to where I came from before. It's a pretty small town in San Luis Obispo. Lots of different bars and restaurants and parks and everything like that, and there's just a lot outside the city. So going camping this weekend on a river, going to float down the river, and then last weekend was out in Bend for a friend's birthday. So lots of exploring in the area, hang out with friends, hang out with my girlfriend, hang out with my cat. But that's kind of everything. I have a pretty wide range of I guess hobbies. I guess like in the winter it was all snowboarding. Now it's like maybe mountain biking or rock climbing or something else. But yeah, I really do enjoy where I live. There's a rock climbing gym like 2-minute walk from me.
Wow.
Pretty much in center of Portland, so easy to get everywhere.
That's very nice.
Yeah.
So you're enjoying the city life more than the small town life, college town life?
For now, I don't think I'm going to enjoy it for long term, though. I mean, I think I definitely am more of a small town person, but it's cool to experience for a little bit.
What makes you say you think you're more of a small town person?
I don't know. I like slow a lot. I would totally go back there. Just after 10 years, wanted to try somewhere new.
Yes, and try out a really exciting opportunity.
Yeah, exactly. Yeah, it was kind of too hard to pass up something like this. It was like low risk and to see if it could work out.
And you've gained so it seems like you've gained so many skills.
Yeah, definitely. Yeah, I don't know. We'll see if I ever want to run a business again after this, but if it's successful, everyone says we'll be, everyone will be asking us to be their, CEO or, do something new basically. So we'll see what ends up happening. But I've always just liked being an engineer. I never really dreamed of running my own business, but it's a cool experience.
I hope wish you the best of luck in it, and that would
Thank
be
you.
awesome. I mean,
Yeah.
being a CEO sounds, like it has its own not so great things as well.
Yeah, a lot of responsibility, but yeah, we'll see how this one goes and see if I can reconsider it, after the fact. But yeah, hoping our company just keeps growing and finish up our investments. We're able to prove out our technology and actually, helps out some people and does a good thing for the world instead of, what a lot of other maybe big companies are doing.
My guest today has been Justin Gravett. Thanks for coming on the podcast, Justin.
Great. Thanks, Krish.